The HSPF is the heating season performance factor. That has to do, obviously, as it notes, on the heating side. That's going to be a rating of the heat pump. The higher the rating, the more efficient the unit is on the heat pump side, okay? And those are going to vary anywhere from, on the low side, the equipment that's out today, around 8 up to about 12, 12 and a half is pushing it. Same thing as you're driving your car down the highway and it's on cruise control. That's when it's most energy efficient. When you're in town, you're starting and stopping, it's the least energy efficient and it's the most taxing on the equipment. Same thing here. So, Kevin, you want to explain your pictures here?
Yes.
You love this part, so I'm going to let you.
This is exactly what I was explaining, is in the shoulder seasons, we need heat. Most people would agree it's 45 degrees out all the way down to, you know what I said, but in most cases very comfortably down to 17 degrees. This heating system is basically the equivalent of driving around in this car with that engine. I mean, it's not going to be very efficient. I mean, and it's quite absurd, to be honest with you, with people that understand energy efficiency. Because what you really should be doing is, in these shoulder seasons, is utilizing a much more effective and efficient means of going around. Now, you know, I'm not going to win any drag races with that thing, but I don't need all that power in the world during the shoulder seasons, you know? That's when this is going to be, frankly, at its most effective, where this is going to be at its least effective. And that's really what, in my head, that's what it looks like when people are operating these boilers in the shoulder season. I'm imagining them driving around in cars like that. And it was just kind of a visual, but that's in essence what's happening, is you're applying way too much machine when you don't need it. And now with the inverter technology, with the heat pump, we can still get to the exact same comfort level, but it'd be like driving around in a little Prius. 5-foot line set. If you go over 25 feet, you have to add 0.21 ounces of R410A to that line set per foot. The only way to do that is by weight, is literally have a digital scale, and you can program these to do a couple of different ways. You can program it at that certain point, it'll automatically shut off, or you add or subtract, however you want to do it. But the bottom line is, please understand that 1.5 ounces of R410A can totally screw up the efficiency of your ductless unit. That's all it takes. So it might work, but you might not realize that it's actually working at more pressures and at lower COPs, and you're going to freeze up coils faster. You'll have pressure issues faster than you would, so it's not a good idea to be using anything but.